I'm glad to see you folks. It actually shows me that you are very interested in this topic, which is exactly the kind of folks I want to talk to. So we will today talk about sustainability initiatives and focus areas in Open Compute project. And thank you, SNIA, for giving us the opportunity to talk about this work going on in OCP. I am a part of Microsoft Azure Storage, Shruti Sethi, and I'm also a part of the sustainability leadership team under OCP, under Open Compute project. So with that, let's actually quickly look at the agenda we will talk about. So I'll spend like 2 minutes setting some common terms and context so that we can have a conversation. So we'll repeatedly refer to like embodied carbon and operational carbon. So I'll just spend 2 minutes to set that foundational context. And then we look at OCP sustainability's history and how it has grown. It is the youngest core project that's set up under OCP. And then what are the focus areas for OCP sustainability, and what work and work streams are already kicked off or looking to get kicked off soon, and what are they targeting? So we'll go look at all of this. I do want to call out that a lot of this work is, certainly not me. I might be standing over here, but there are a bunch of folks and companies who are helping drive this, being involved in this. John Michael sitting here is very deeply involved in driving it also. So I would like to call out that it's thanks to a lot of these folks, and maybe a few more of you folks will get involved soon. Okay, so setting some context of terms here. So we'll talk about like total carbon cost, and we are essentially then referring to the total carbon impact coming from two different components, what we will call the embodied carbon component and the operational carbon component. So embodied carbon component means think about the carbon impact coming from right from material sourcing to manufacturing, transport, installation of equipment. And then the operational carbon impact, think about the use phase of the devices, so power, energy used during the operation of the devices. So these two are the main components. So whenever we refer to like total carbon cost, we are referring to the sum total of these. Okay. With that background, okay, let's start talking about OCP sustainability. So like I said, it is the youngest core project that is set up under Open Compute project. And Open Compute project works in multiple legs. I think some of you I do see in the audience who are already involved in some of the legs. Like there is a group for essentially storage, security, networking, hardware management, and sustainability is one such core setup. It does aim at providing open source and standardized resources so that best practices for like reuse and reusability and circularity can be employed by the data center value chain members. The efforts began in 2019 and finally taking the first fruit in 2022. 2022 was when this leg under OCP was established. And soon after, sustainability was also made a mandatory fifth tenet for OCP documents and publications. So what that means is OCP publications look to satisfy certain essential tenets, such as impact, efficiency, scalability, etc. So sustainability was added as the fifth tenet to that and a mandatory tenet, so that all of OCP specifications and publications coming henceforth are actually thinking about how they are positively benefiting sustainability. So that was a big help on OCP sustainability side. And around the time of just 2023 is when we had a bunch of work streams sort of span out of it. And we'll go over what is the work that got kicked off and how it is currently going and what it needs. Okay. So we'll talk about OCP sustainability work in terms of 3 different focus areas. The first one, carbon transparency and reporting. So think of what we cannot measure, we cannot improve. So that is one big foundational area of concentration. Currently in the industry, there is a lot of variability in how carbon assessment is done. And this is basically targeting that particular need where there needs to be some standardization of the LCA methods. When I say LCA methods, life cycle assessment methods, which actually give us the carbon assessment, as well as standardization of how this carbon is getting reported between the value chain members. So this entire leg is focused on that part of the effort. We will double click into each of these, but I'll just give an overview before we go ahead. The second part is circularity and reuse. And I know one presentation also went into deep discussions about circularity. But circularity is seen as one of the major levers that can help carbon just by extending the life or reusing of devices. And this entire focus area is concentrating on enabling that. The third focus area within sustainability, OCP sustainability, is having visibility to and being able to clearly gauge how efficiently the use phase is and how interoperability has been implemented. So all the power-related visibility or power-related metrics that are being set up is under this third focus area. And you'll see a couple of those work items going on. Okay. So double-clicking into each of these, if I just go one level deeper, what we show over here is essentially the breakdown of what are the work items going on under each of these. So within the first one, like we spoke about, the LCA or life cycle assessment standardization, that is one item that is recently getting more of a push. And with standardizing that carbon, also how that carbon is disclosed. And I call it a carbon label or disclosure because essentially that's the imagination of the output that will result from this is like a carbon label, like a nutrition label kind of thing, but not physical, but in format, a similar way, a carbon label. Under circularity, there are 2 different avenues being concentrated on. Of course, if it is drive-related circularity, then there is a lot of need and a lot of push for getting more promising or more confidence on data sanitization. And we look at a couple of things going on under that and also refer to the presentation, I think 2 tracks back that was in this room that was talking about the sanitization criteria. And the other part under circularity is looking to create carbon incentives in order to promote companies or folks actually encouraging the primary and the secondary life use of the devices. Double-clicking into the last focus area, we see a power telemetry and sustainability power metrics work going on. That is essentially trying to provide more visibility into the power utilization at device level, device and system level. And then B, trying to see if do we have enough metrics that are really conveying how the power is being utilized and redefining some of the metrics. So the work for redefining some of these metrics and adding some of the metrics has been started. In some cases, it's at a stage where there is a draft one asking for feedback. So we'll also go over, what has a draft one to get feedback right now. There is a very recent, I'll say, interest looking at, also seeing how cooling and heat reuse is impacting this. And yeah, more push towards that from anybody would be highly welcome. That's not a work stream that has completely gotten kicked off. Okay, so let's talk about the LCA and carbon label disclosure work, which everything comes under the transparency and reporting of carbon. Open Compute project has actually partnered with iMasons, which also has the iMasons Climate Accord group, which highly works on this particular aspect. This partnership is basically having a goal of, first of all, standardizing the carbon label or disclosure format in which the carbon information will be conveyed such that there is better comparability in when different reports are looked at in the industry. And also, it basically helps with conveying the taxonomy of how these devices are all doing in terms of carbon. The other part, which I actually highlight at the bottom over here, which is, I'll say, it is more recent than the upper goals. The bottom goal, which is highlighted in bold, that is to actually standardize the carbon assessment method. Now, the reporting is great, but of course, as a baseline for standardizing the reporting, we also need the method of assessment to standardize. And that basically means pushing the work to build a product category rule. So product category rule can be defined for different kind of equipments. There is some work that was recently done for product category rule for devices in laptops. So we want to push for a product category rule for data center equipments. And that's just recently getting a push. Go ahead.
What do you mean by rule?
Okay.
What are the implications?
Yeah. Oh, yes. So the question was, what do you mean by rule, and what is the implications of having a product category rule per se? So let me give a context over here. So when LCA assessment is done for any device today in the industry, the very first thing is that we have variety of different methods that may be followed. For example, I might say that my foundational unit for doing the carbon assessment is going to be the weight, the kg of the materials used. I might go a different route, and I might say that my foundational unit for the carbon assessment is going to be the surface area of the NAND chips or other devices inside. So picking that kind of a foundational assessment, foundational unit, is where one variability comes in. There is a lot of variability in the industry databases that might be used in actually converting the material and process into carbon impact. So I might look at database 1. There are multiple databases in the industry. I might look at database 1, which sort of tells me that this particular fabrication process using these materials is resulting in so much carbon, XYZ carbon impact. If I change my database, I might have another ABC carbon impact. So because of these database variations, again, the LCA outcomes are going to be different. A couple of other, different attributes can also vary. But what I am bottom line trying to point to is this basically means carbon assessment done by, say, me versus Ari might result in completely different, carbon, net carbon, kg CO2 values. And what a product category rule would do is try to standardize some of these aspects. And I do say some with an asterisk marks because, of course, as standardized, as many attributes are standardized, that much better, but there might be some limitation to what can be done over there. But it will try to standardize these methods and attributes that have to be picked so that the entire industry hopefully is going to converge to doing the assessment in the same way. Yes?
So companies like Microsoft and Seagate, we use these third-party companies like Makerside or encompasses, and we have budgets for that. We have pretty healthy budgets for that. I've been running into some companies that don't have those kinds of resources. So what would you say to the cost of doing this for the entire ecosystem for each company?
Yeah. So, oh yes. So the question was that a lot of companies like Seagate and Microsoft, they have a good amount of budget that is allocated that can, take help from maybe third parties, et cetera, in order to, or tools that can do these carbon assessments. But across the value chain, there may not be the same kind of provision for all the companies. And my thoughts on that is essentially so we are a little bit, we are not early. I wouldn't say we are early. We should actually hurry up. But we are at a place where, yes, doing the carbon assessment is not completely an everyday process. It's not like when we have power assessment of what this device uses, we also have a carbon assessment of what the device has taken as a carbon hit. Since we are not at that place, getting this consultancy help or getting the tools that are actually going to help this aspect are slightly more on the dollar side right now. But I sort of envision that as this becomes more of a standard practice, a lot of companies will be able to build in-house expertise in order to do that. B, also these tools should be available and more economically, considering that now that becomes a little bit more standardized practice. So it is early in the cycle, it's going to seem like a harder lift, and that is certainly there. But it's sort of a helpful circular loop. The more the industry does it, hopefully it gets easier to actually do. It also gets more refined, and that helps the entire circle. So, thank you. Okay, so going ahead on that, this particular work stream that has actually begun is currently being led by Microsoft, Google, Meta, Schneider Electric included. It also actually includes some research institutes that are trying to lead some of this work, such as Fraunhofer Institute. And currently they have started, the first item over here, the carbon label disclosure format. Like I said, this got kicked off earlier than the product category rule work. So currently they have been looking at what are the standards and means of expressing the carbon format that exist, how comparable they are, and then trying to issue a first draft of what the disclosure form should look like. So they have actually put out a first draft of what the proposed disclosure form should be, and they are looking at getting feedback from suppliers and other portions of the supply chain also, of the value chain also, getting feedback on whether this form now has the required amount of inputs. Are there questions that it is asking that may not want to get conveyed, or are there questions that it is missing? So it's in the getting feedback kind of process right now, this very first draft of the disclosure form. So one thing I would encourage is, of course, you would have to go and look at the OCP sustainability site and look at the disclosure form, or feel free to reach out to me and I can certainly point you to it. And please give us feedback on what this disclosure form means to you, whether it's adequate, inadequate, too much. So, yeah. Okay, I'm going to switch gears a little bit and go to what was under our second focus area. So I'm out of the carbon reporting part. And the second focus area, which we also spoke about in the morning quite a bit in JM and Ari's session, which is the circularity portion. And as you see, Open Compute Project is closely working with CDI, Circular Drive Initiative over here, in order to drive the reuse of drives as well as devices, of course, in general. So the goal over here is twofold. One is to have a better confidence on the data sanitization, because that helps the reusability of drives, so that portion of reusability. And the second one is having carbon accounting in case of circularity. So currently, our accounting rules do not actually state how the carbon should be shared between a primary user and a secondary user, or what happens when maybe internally there is a secondary user, but you need to understand how this carbon is going to be shared. Should it be taken in the very first year? Should it be taken spread out? So there aren't good rules in order to estimate how this carbon impact should be shared, which actually leads to either in some cases only one of the bodies taking the entire hit of the carbon, or it might lead to double counting of it if both the bodies are trying to take the accountability of the carbon. And such kind of lack of clarity actually discourages the reuse from happening. So we are actually trying to also work on creating some incentives for the primary and the secondary users to actually push for the reuse to happen. Okay. So I'll point out a few factors that are encouraging or discouraging the circular reuse. We spoke a lot about the data sanitization, and OCP outside of sustainability is also working on the lock, safe, Calyptra, and other rules which are basically going to help gain confidence on the data sanitization. The other aspects that we looked at, if you see this one, that is the third one over here. Sorry, I skipped one. The third one over here, this is actually tied to our first focus area, which basically says the carbon assessment, first of all, has to be a little bit more standardized and agreed upon. So that is actually becoming a very foundational thing that is affecting all our other work. The last one that we looked at is basically creating the incentives, right? So the four things this is pointing out is, let's gain confidence on the sanitization. We certainly need visibility into the lifespan and performance, or the health. Like that is, I do not write a note over here because we actually do not have a work stream actively working on that part. Would love to have one if somebody has the time and encouragement on that part. Then let's make sure the carbon assessment is uniform across the industry so that when this carbon is allocated or when we have these discussions of carbon exchange, there isn't a discrepancy and I'll say lack of agreement. And then lastly, let's provide incentives that push folks to do a second life or extend the life usage. Right? So that's all tying into, these are the main areas all tying into driving the circularity and reuse that OCP sustainability wants to push for. Okay. So this paper got called out earlier also, which is basically a call for research on storage emissions, particularly storage. And actually, when it got called out earlier also, there was one question that I could not raise my hand and answer, but there was a question about, there is 61% coming from embodied carbon, and there was a question about, is that only storage, or does it include memory, etc.? So for this work, that is actually all the storage nodes or storage systems. So it is not just storage drives. It's actually a study done on all the storage nodes, including the drives that they service. And 61%, which is a major chunk, is only embodied carbon, according to this work. I would want to double click and point out one more thing. So I don't know, if some of you folks were there at SDC last year, I got the opportunity to come to this stage last year. And we actually looked at the comparison of these devices, the processors, memory, SSD, and HDDs. And with the work not being complete and refined at that point, we had actually rated the carbon impact in qualitative terms. We had actually given very low, medium, high, and there were a lot of questions about how much does that high mean or how much does the medium mean. So I think this would give a little bit, good perspective now that we are able to put numbers behind it. So one comparison that I would want to point out is if you look at SSD's contribution to an SSD storage rack being 80% versus an HDD contribution to an HDD storage rack being 41%. So that also gives us a little perspective of, in the entire storage system, what is hitting us most in terms of carbon. Yes?
What is other? So I see HDD at 41% and then other 33%. Is that fans or what is that?
So the other might include a couple of things, right from chassis. Oh, sorry, repeat the question. Yes. So the question was what is included in the other section over here. So because we say processor, DRAM, SSDs, HDDs, and then there is an other. Now that might include a couple of other things, right from chassis to cabling to nuts and bolts, NIC cards. So yeah. Okay. So this is storage systems being analyzed. So that is why it's not GPU nodes being considered over here. Yeah. Of course, that breakdown might be different. Yeah. Yes. The paper, so one important thing, the paper does call for certain approaches to reduce carbon and look at for pro-sustainability, and it heavily does call for a second life of use or extending the life of use, which is why we were highlighting this under the circularity aspect. It is a major lever, 61% according to this coming from embodied carbon, and embodied carbon can greatly be helped by reusing. Okay. I will again switch gears. So if you remember, we had 3 focus areas. So I'll switch gears to the last focus area now, which is the power sustainability metrics and efficiency and how we view them. So there are a couple of work items going on under this. The first one I highlight over here is the sustainability power metrics work. They are basically looking at, first of all, seeing whether the existing metrics are in the current day conveying whether it is good or not good power usage. So analyzing the current day metrics and then looking at whether there are other metrics that need to be defined. And with the initial work, they have basically put down a goal of redefining or defining PUE, power utilization, IUE, infrastructure usage, and then carbon utilization efficiency. Yes?
So I don't know what good power usage is versus bad power. Can you explain what that?
Okay, so the question was, what is power usage versus
No, good versus.
good?
Good versus. I mean, if a customer tells me he wants to run really hot, I have high power, that's what he wants, is that a bad thing or is that a good thing? I'm just trying to understand what good and bad means.
Yes. So the question was, what is good power usage and what is bad power usage? So with reference to this particular work, the work is not trying to define whether the workload needing X amount of power is good or bad. All it is looking at is how much power is actually used towards computation, so the real workload, versus how much power might be for non-IT purposes, including thermal losses and other kind of idle states. So that is its definition of good versus bad. When more of the power is actually for the real computation, that is a good. So. That is slightly true. You'll see actually on the next slide. So yeah, I would like to point out the first white paper for looking at the PUE, so power utilization has been put out. It can get more feedback still. It has been in the feedback loop for some time, so it has gotten a number of comments and feedbacks already, but it's not finished the loop. And the other work that has already begun is on IUE. There is a 1.0 first draft for defining the IUE, the infrastructure utilization efficiency. And that particular first draft is certainly just going into feedback loop. So these are other 2 places where we would love to request if folks want to have a look and let us know their feedback. So I realize that as I'm proceeding with this, I'm pointing out more and more areas where you folks have action items to go look at it and give feedback, which is very nice from my point of view, but I don't know how you are, if you are hating me for it. Anyhow. Okay, so let's look one level deeper into what these papers are sort of trying to say. We'll not go into the complete depth right here, but this will give a little bit of gist. So what this work is actually analyzing is not just looking at what is IT power and non-IT power, but it is actually trying to see what is the thermal power loss, thermal power, the power conversion losses, idle power that is actually a part of that net total. It is then trying to define that, okay, if the IUE at a particular load, let me actually mention one thing. Why do all of these things say at a particular load? Is because that is one major item that this work is calling out. Currently, when we report PUE, we are actually not calling out exactly what load that is on. But what happens is, our thermal power and some of the other losses, they go unchanged depending upon what is the current load. And that one major thing that this work calls out is that all of these reporting metrics need to be reported at a particular load. So there needs to be some understanding of what load they were measured at. Given that, we define an IUE that would be the computational power upon the total active system power. And that essentially tells us that the existing definition of PUE, which is the total energy on the total IT energy, is nothing but the IT energy being IT computational energy as well as the IT non-computational energy. So it's pointing out that the visibility into that breakdown is actually essential. Because of all of this power, what is the real useful power that is being consumed is the IT computation energy. So we need to have that breakdown where it does not only go with the IT energy, but also points out what of that is IT computation versus IT non-computational power. So that is the other part that this paper is trying to emphasize. Again, please do reach out or look at the OCP sustainability website and give us feedback on details of both of these. Okay. I will talk about one last work stream that is going on, again under that third focus area, which is related to efficiency and metrics and power. This particular work stream is, it's called the power telemetry work stream. So as the name suggests, it's related to the telemetry. So it is basically emphasizing the importance of more visibility into how power is being utilized, right from the device to the system level. The workstream has proposed a sustainability power profile, which includes a basic power profile for each of the device level, which includes the basic product identification. So it identifies the device. It talks about what is the power utilization of the device, also the sample rate at which it is being measured over time. And this would be, along with that, the product location. And this would be reported via a redfish interface, or that's the current proposal. So it has tried to define a template for the device to report its power consumption at the sample rate through the redfish interface. The entire, on the right is just a snapshot of the template. Of course, it's a very small part of the entire template. The entire template is much longer. But essentially, this particular work is also out in the first draft form. So you can actually have a look at that entire template and the description that goes along with it and read about why are these factors the ones that we have included that the device needs to expose. Why has it looked at redfish as the interface that exposes it? Hopefully that's so that it makes it easier for the BMC, et cetera, in the device, in the systems to monitor this power. And let us know any kind of feedback on that. One thing to point out is this work is not defining a new metric, or it is not a mandate on how the power should be used. This is purely towards visibility. So this is only asking for more telemetry or visibility into how the power is used in the devices. I think with that is the last part of, so 4 different papers and templates, et cetera, that are actually out there to get feedback right now. Sorry, go ahead.
So roughly what's the sampling rate on this? And sort of what's the intent? What I'm trying to get at is, I'm a former employee of an electric gas supplier, so I probably know a fair amount about this from their perspective.
Okay.
Peak power and demand charges are significantly different than assuming a level load.
Right.
And so where does this fit?
Okay, so the question was that what is the sampling rate being proposed, and the context of the question is that when power is charged for, the peak level charges are different from maybe other time charges that they're facing.
A peaking charge and a use charge.
and a use charge is different. Okay, a peaking charge and a use charge is different. So one particular thing is that while doing this work, the concentration is not really on getting to how much is actually spent in terms of dollar, in terms of the power. So that's not been the concentration over here. The idea is basically to be able to understand the power that is being utilized so that it can be converted into a carbon impact. Now, carbon impact depends upon what we call the grid intensity factor, which varies from location to location. And thanks for asking me the question, because that is the reason the location of the product is being exposed over here. There is some understanding that this grid intensity factor also has like a peak and a stable other time usage difference. We have not proceeded to sort of propose that whether a peak time intensity factor should be actually picked up or whether it should be like an average or a weighted average. We have not proceeded to that part of the work, but where this is actually getting to is so that it can get to that part of carbon impact.
One follow-up, quick on the reason that it matters from a carbon perspective is that the carbon intensity of your grid intensity?
Grid intensity, yeah.
So the carbon levels of grid intensity can vary by orders of magnitude because the base load can be supplied by very sustainable power,
Yes.
hydropower, solar, wind, nuclear. But your peaking power can be very dirty sources.
Yes. So I guess not so much of a question, more of a comment, but let me repeat that. And our colleague here was pointing out that the grid intensity, which decides how much carbon impact this power has, can vary quite a lot depending upon whether that is a peak time or a usual functional time. And that is because, yes, a lot of these power grids that we get our power from, there might be some time of the day or say some time of a regular cycle where there is a lot of renewable energy that is coming into the grid, which is essentially decreasing the carbon intensity of the grid. But there might be other times where they have to support some peak power usage, and at that point, along with the renewable energy, they might have a lot of dirty sources of energy that are feeding into it also. So according to at what point in time that power is utilized, we should be careful of how much carbon impact it actually can have. Thank you. Sorry, there was one other hand.
I was just going to, and I don't know enough about the power state, but I think from the data center side, it's usually 24/7, and it's usually pretty consistent. And correct me if I'm wrong, you're on the data center side more so than I am. So I'm wondering if we can just take averages, and that's good enough. But then again, it could be, the more I think about it, there could be like a region-wide emergency where suddenly everybody's looking out. So it's complex, I agree. But I like to try and make it simple.
Yeah, so from, having not actually done the study as a part of this, like I said, we have not proceeded to that, but there is some, cyclic kind of behavior that is observed. Just like there is a reason why the power companies charge differently at a peak time because they see a cyclic behavior. There are, times where you see a lot of activity even in storage systems, in data centers. Not only depending upon time, it might also be seasonal, depending upon very layman factors such as, is this a holiday season or is this like a core working season? There is no vacation in schools, no vacation in companies. All of those actually seem to impact. And we don't normally think of those factors, but the carbon intensity, the grid intensity changes quite a bit when all of this does happen. But yeah, we should be looking more into that to understand. Yes, go ahead.
This looks to me more like a pure power profile than sustainability profile. If we were talking about sustainability, I would expect to see some amount of comparison of energy to work done, so that I know if
Right.
it's effective carbon or not.
Yes. So the idea is that the previous work stream is sort of trying to capture how much, real computational power is used versus power is used, total power is used. So this particular part of the work is trying to capture exactly what, you are hinting towards, that this much power is used, but effectively how much of that power was towards real computation or actually handling workloads, versus the second work stream is right now just trying to concentrate on creating power telemetry visibility that can go ahead and help gauge the carbon impact, etc. There is a, I'll say, insight into the fact that these two work streams need to do their foundational work and probably come together. Has not happened yet, but yeah.
There is a SNIA group right now, the Green Power Quake,
Okay.
putting out a device power test,
Okay.
which will,
Okay.
for storage devices, hard disks and SSDs, tell you for random writes, for sequential writes, for a bunch of different conditions, what the watts per, what the IOPS per watt are, or the
Okay.
megabytes per watt are.
Okay.
And every device is going to have a different fingerprint on that stuff. And I'm not seeing any hint, which is going to help me decide
Mhm.
whether this is actually an effective device or actually a wasting device. Is this
Yeah.
a device that we're using and we now know continuing to use it is a carbon net loss for us, as
Mhm.
opposed to shelving it, throwing it away,
Mhm.
or is it something we should keep using?
Okay, so I think, so let me first repeat what you're saying. So the first thing that you pointed out, that SNIA has a power test that they are basically, device power test that they are publishing that could help sort of give a gauge of how much power for how much usage of IOPS is being given by that particular device in order to understand at the device level whether it is efficiently using power. And I think just to reply to that, one place where we have not sort of gotten to is we have not looked at the device level marking whether how efficiently that device is sort of doing that work. The previous part of the work that I was pointing out is actually doing that at a system level. So it's doing that particular activity, but at a higher level. What you are pointing out is that there is a need to have that understanding at a device level, whether the workload versus the good power consumption, how does that metric look at a device level? So,
Just to follow on that, those specifications are called SNIA Emerald.
okay.
It's the basis for the US EPA Energy Star certification for
EPA?
a lot of data centers.
Okay. Okay.
So it's pretty widely adopted. It is also some of the basis for the European standards and the Japanese standards on IT, energy efficiency.
Okay. The details of this, I actually want to let you repeat on mic.
Sure, of course. Yeah. Just say
But-
SNIA Emerald.
Yeah, so I understand that it's this particular device power test that you're talking about. Is that the one that is called SNIA Emerald?
It
Okay.
is a new offshoot of that group.
Okay, okay. So the call out was to SNIA Emerald work, which is basically is also driving the device level power test that is going to be put out. That essentially concentrates on how well the device is actually using the power for computation. But yeah, so I understand some of the things being called out here is that like we are looking at the system level to understand how well the power is being utilized. There might be a need to look at it at a device level also, which is a great call out. I don't know if maybe SNIA and OCP can work together. Yes, we'll see about that. But okay, I think that was the last part of the work that has been going on in OCP that I did want to point out. In this entire process, I have pointed out 4 different drafts or papers where we could really use immediate help. And of course, the main call out over here is also please do join us in the efforts in OCP sustainability and also SNIA, working towards all the power efficiency and other sustainability and carbon impact work. You can directly go to this website or feel free to also reach out to me as required. I will pause there. That was my time. Happy to take if there are, I know we have been conversing with questions, but if there are more questions,